Pastor Dames and others. We understand we have two groups this evening, both on Facebook Live as well as Zoom. My name is Angela Hill, and I'm a professor and associate dean for clinical affairs for the Tunisia College of Pharmacy. I'm also the project director for We Care. And this evening, we have our team, which consists of Dr. Deborah Austin from Reach Up. On the line, we also have Mr. Hiram Green, who is all things public relations for both the college as well as Reach. If you raise your hand, Mr. Green. And then we also have our illustrious dean. He's Dr. Kevin Sneed, who will be providing the information for this evening. And so we want to certainly extend our thanks and gratitude Temple and all of those that are in attendance for allowing us this opportunity to be with you tonight to talk about COVID, but particularly the vaccines, since we know that it is one of the hottest topics right now. This pandemic has just impacted our lives in ways none of us imagined. And We Care has been dedicated to making sure that we try to bridge the information gap, certainly dispel some of the myths out there, share with you some of the facts that we know, certainly being one affiliated with an academic center, but secondly, being trench level as it relates to the day-to-day scientific developments and clinical initiatives associated with care of patients with COVID. So tonight, we are going to have the privilege of appreciating Dr. Sneed's background. He is pharmacist first, but he got a biology degree with a minor in microbiology from the University of Central Florida and went on to get his pharmacy degree from Xavier University. And he is credentialed in so many areas. He's practiced as an ambulatory care specialist in the Tampa Bay area for 20 plus years. And as I mentioned, in his spare time, he started the College of Pharmacy. And so we are going into 11 plus years in operations, and we are one of 140 some odd schools that has one of the most innovative and visionary curriculums, as well as dynamic faculty, and it's all under his phenomenal leadership. Dr. Sneed is very passionate about helping the community. And he actually founded We Care after working as a part of a health equity center years back with Moffitt and the College of Public Health. They had a big federal grant that afforded them to, at that time, focus on issues affecting the Black community like prostate cancer. Once that funding ran out, he came up with the concept of We Care as an attempt to continue the mission of educating certainly minority and diverse communities about the importance of research participation, but certainly trying to close the gap of health inequities. And so one of the things that we have been doing since the start of the pandemic is offering virtual workshops like this, panels, participating in all kinds of radio and interview moments to just really talk to any and everybody about COVID, ways we can prevent it, by following the CDC guidelines, but also making sure that you understand that COVID is real and that certainly the vaccine will offer some hope, but wanting you to be empowered with information as you have to make decisions about whether you and your family are going to consider taking the vaccination. So with that, I'll stop talking and introduce to some and present to others my supervisor, my colleague, my mentor, and my friend, Dr. Kevin Sneed.
Thank you, Dr. Hill, very much for that introduction. And obviously, and every time, I would love to once again just thank Dr. Deborah Austin and Reach Up Incorporated for being our community partner here for so many years now. You know, when COVID-19 started, we didn't have to scramble and go out and try to find somebody. We turned to our partner who had been with us right from the very beginning. And so I just want to thank Reach Up. And we're going to show you all just a quick video here in a moment. I'm going to share some brand new information even this evening. It's a very visual presentation. I have a couple of video clips I show each time to groups to help them better understand a little bit more about the virus. But overall, we're going to try and get through it relatively quickly because I really want to spend more time doing question and answers and taking your comments and really helping you all to be able to be more informed, to be able to make a decision about whether or not you would like to have an opportunity to receive the vaccine. So we're going to go ahead and get started here. And I'm going to share my screen, and we have a PowerPoint presentation to start off. Okay, Dr. Hill, can you confirm that you can see that for me?
We can see it.
Okay, very good. Very good. So, well, why do we care? Why we care? Why this program? We want to improve health outcomes.
The collaboration between USF Health's Tunasia College of Pharmacy's We Care program and Reach Up Incorporated aims to bridge the gap between underserved communities and access to care. We Care's mission is to increase the representation of diverse populations in clinical research. It starts with rebuilding trust between academic and clinical institutions through educating and empowering the community, and then providing research opportunities along with protection and advocacy for the participants.
They want to hear the story from folks who have been through a clinical trial.
You have to share all of that information with everybody.
So take the opportunity to have a better quality of life in our communities. Join us.
So again, I just really wanted to start off and kind of show you all a latest video, a true gem here in our Tampa Bay community. And as mentioned before, we'd also like to acknowledge AHEC and the Tunasia College of Pharmacy. But let's go ahead and talk about the coronavirus. Let's talk about it overall. Now, this coronavirus, it's not new as a family. Previous to what we're experiencing right now, there had been 4 common coronaviruses, and they caused the common cold and in some cases even the flu. It's been projected that when people thought they had the flu, they probably had a coronavirus. As much as 10% of actual flus around the country were caused by the coronavirus. Now, back in 2002, many of you may recall that we had SARS. And it's very important to understand, again, that's a type of coronavirus. Now, as deadly as SARS was, and believe it or not, it was more deadly than what we're experiencing right now. Worldwide, there were less than 10,000 people that became infected by it, although the mortality rate was over 800 people, so greater than 10% of the people died. A number of years after that, 10 years later, we had MERS, and many of you may recall. Again, MERS was not nearly as widespread as SARS, and so now in 2019, we had the newest coronavirus that came out. At the time, we called it the novel coronavirus, or SARS-CoV-2, as we call it. And the one thing I would like to really just share with all of you, if you take a look at the trajectory of when these viruses have actually jumped over into humans, we started in 2002. 10 years later, we had the next one. 7 years later, we had the next one. And so we have to be aware that there could be another pandemic sometime in the next 4 to 5 years if we stay on the current trajectory. Now I'm going to show just a quick video here. It's an animated video just to give you a sense that yes, the virus is real and what it actually does in the body. And we have a couple of videos like this that we'll show and display this evening. Uh-oh. Okay, something went wrong there. Dr. Hill, am I still screen sharing?
No, we're seeing it's back to our pictures showing.
Mm-hmm.
Okay, I apologize for that. Okay, we're going to try this again. I think I can get that queued up again pretty quickly. Of course, technology never works when you really need it to. Well, I tell you what, we'll get past that just in case there's something wrong with that video.
We can see your screen now.
Okay, are we back up?
Yes.
Yes.
Okay, very good. So apologies for that video, but hopefully that won't persist with the next two that we show. Now, what you're looking at right here is a single cell in the human body that has been infected by the coronavirus. And so you can get a sense of exactly how small they are if that's a single cell in your body and why we have millions of copies in your body. And now it's really important to understand also that the coronavirus, we've been able to measure and monitor this whole thing for a very long time. These are actual electron microscope photographs of the coronavirus. And even though they kind of superimpose a lot of color in there, if you look on the outside, it looks like the corona of the sun. Now, the other question that people had early on was whether or not this coronavirus was actually a part of bioterrorism, or was it made in a laboratory and escaped out? Well, everything that we've been able to do from a genotyping standpoint, kind of like what I call 23andMe for viruses, has indicated that it was a natural mutation that occurred. And if you look up in the top left corner, and it may be difficult if you're on your phone, but in the top left corner, we can see the various mammals and people, humans and raccoons and bats, and where the virus actually resided and where it mutated and what animal it actually mutated in. And so, no, this, as far as we can tell, it was not a component of bioterrorism. It was not man-made in a lab. And we actually had people on the ground for many years that were going out and trying to find these viruses before they became infectious in people. Now, you all have seen this image. It's the most widely shown image for the coronavirus, the current novel coronavirus. I really want you to bring your attention to the red spikes on the outside. It's called the spike protein, or the S protein. And in just a moment, we're going to reveal how important the spike protein is, not only for how it infects your body, but how the vaccines actually work. So all human beings have a receptor in our body called the ACE2 receptor, especially as an adult. And it's all throughout our body, and I'll show that in just a moment. That spike protein attaches on to that ACE2 receptor, and then from there, it gains entry into the cell where it begins to replicate and multiply by the thousands inside of that individual cell. Now, it's really important to understand, as an adult, many of us have this ACE2 receptor. And as we continue to have other medical conditions, sometimes the ACE2 receptor is even more active. And so we really want you to kind of understand exactly where and how the virus attaches onto your body. Think of like a little fur ball attaching onto Velcro. And the Velcro on the outside are the red spike proteins. I've only put this cartoon in to try and show everybody that from the very beginning, we did not have any medications whatsoever to try and treat the coronavirus. And so we turned to a lot of medications that had already been on the market for a period of time. And even in the very middle here, you might see, if you're capable, you may see the word hydroxychloroquine. And we began studying hydroxychloroquine to see whether or not it could be a therapeutic. Now, we understand now that it did not do very well. But way back in the original SARS, that was one of the medications that we explored as a potential therapeutic agent to help treat it. And that's why they quickly pivoted to try and treat the current novel coronavirus, or COVID-19. Now, one of the most important things for all of us to really understand is that if you have any chronic conditions, for any human being that has a chronic condition, and I've listed a few here, diabetes, high blood pressure or hypertension, obesity and overweight, people, we kind of questioned about smokers and maybe those that have asthma or COPD. Any one of those conditions actually kind of puts into place an environment that allows the virus to come in and multiply extremely rapidly. Now, for individuals that have these conditions, already long before the coronavirus came along, there was internal vascular inflammation and proteins along with that inflammation that can occur in the body. And so what has been occurring and why this particular coronavirus has been so deadly are people that have these conditions. If it does infect you, it can actually turn on these inflammatory proteins. And if you look all the way to the far right, when those inflammatory proteins, when they really get revved up, And I mean, they turn on in a big way. It's called a cytokine storm. And the cytokines, they're kind of like the messengers in the body that tell the proteins what to do and how to do it. And so the cytokines in this case, they rev up, and it's almost like almost like a hurricane of inflammatory proteins. And if you look at the very bottom, the more of these inflammatory proteins you have, the sicker you likely will become as an individual. Now, I've had a very busy clinic week, and on yesterday, one of my patients that's a diabetic, it was really important. We have kept her so well controlled for a very long time, and she became very ill with the coronavirus. But I told her when I went through and looked at her labs that because she has such good control of her diabetes, we probably never allowed that cytokine storm or this internal inflammation to occur. So this is going to be a very important thing when we talk about the really bad and deleterious effect it has had on us as African Americans. Now, the other component, and as Dr. Hill mentioned, I have a background in microbiology. I was on my way to go and study immunology and get a PhD in that area, but I chose pharmacy, I think because I wanted to join Dr. Hill in that profession. But overall, I have never in my life really seen a particular virus that can do everything and as many different things in the body that this particular virus can do. And so here I'm going to show you a couple of different areas of the body and help you understand exactly why this is a very unique virus and why it has become so dangerous. If you look on the far left under the neurological area, yes, it's very common. People can always have a headache from almost any virus. It doesn't really matter what it may be. However, we began to really begin to understand that people were now having a sense of loss of smell and taste, along with other neurological effects that you see here. Some people were having strokes, and I'll come back to that in a moment. Another really key thing that we noticed early on were the amount of people that had acute kidney injuries. We hadn't really seen a virus cause that kind of injury before, not the way this one does, and not one that was so widespread in the population. Early on, we noticed a lot of people were having diarrhea symptoms. That was a key symptom. We didn't all the way understand what type of consequence that may be, but I'll show you exactly why that began to occur. But a couple of months after, we began to get reports out of Philadelphia and all throughout the Philadelphia core or the Northeast corridor, Washington, D.C., right up into the Boston area, about people that were having these clotting factors. And we read the reports early on. And so people were developing DVTs, or deep vein thrombosis, that was actually now traveling and lodging in people's lungs, causing a pulmonary embolism. And then, unfortunately, we began to see many more heart attacks that were occurring. Again, the initial reports were coming out of the Philadelphia area from their hospitals, and very quickly pivoted to the Boston hospitals, where they were reporting damage to the heart. Okay, so what we call myocarditis, and we can talk about that more in just a moment as well. So as I've already mentioned, this is not just a respiratory virus. It's not just one that we talk about it because we have to wind up ventilating people because of the negative effect it does have on the lung. But you can begin to see all of the various areas of the body that can be affected by this. And it all comes back to that ACE2 receptor I talked about earlier. That little receptor is in all these different areas of the body I'm showing here. So even though we don't find it as nearly as widespread in the lungs, but we have a lot of lung area, so that makes it a very prime target, and it's a respiratory virus. You can see we have ACE2 receptors in the heart, and we have ACE2 receptors in the gastrointestinal tract and in the kidneys. Very high prevalence and expression, what we call expression in the kidney. So an individual that becomes infected by this particular virus, when it begins to travel throughout the body, it can attach onto any or all of the various organ systems that we're showing here, and thereby causing a very, very big health problem for the affected individual. We're going to try and show another video here. Hopefully we have a little bit more success than we did with the other one.
In a world where millions of lives are under threat due to COVID-19, it is of vital importance to gain a better understanding of how the virus actually works in search of a cure. The surface of the virus particle is covered with approximately 100 spike proteins. They always come in groups of 3, in which the proteins are intertwined. Each individual protein consists of 2 parts. a globular head called S1, and a stalk-like structure called S2. One of the three heads is slightly bent, enabling it to connect to the so-called ACE2 receptor on a human cell. Once the connection between the virus and the receptor has been established, the human body activates the TMPRSS2 enzyme. This is a protein-cutting enzyme that proceeds to cut off the head of the spike protein. This causes a change in the structure of the virus. The S2 protein now grows longer, penetrating the human cell. The protein then retracts again, bringing the membranes of the virus and the cell very close to one another. At this point, the virus can enter the cell through a process of endocytosis. It engulfs the cell with its membrane. The virus has successfully invaded the cell and can now start to multiply, ready to overrun the system. However, we have strong defense mechanisms that try to prevent this from happening at all costs. Scientists recently discovered how our antibodies react. It's actually a very simple process. Our antibodies bind to the spike head, or S1, thereby preventing it from connecting with the ACE2 receptor and stopping the virus from spreading. Understanding exactly how this process takes place is key to the rapid development of a vaccine, making it an essential part of our ongoing fight against this global public health crisis.
So let's go ahead and talk a little bit more about how we got there and how these vaccines even came about so quickly. I know many people have that question. As you saw in that video, anytime you become infected with something, your body's going to try and mount an immune response. Now, this is very busy and very difficult to look at, but if you go back behind to the left of the black line, from the time an individual comes into contact with the particular virus, if you move forward, it's going to take anywhere from probably 7 to 10 days before your body begins to really mount a very robust response with antibodies. And it's during that 7 to 10 day period that we find that very often a lot of bad things can occur. First of all, the individual may be asymptomatic and not even know they're infected. And it's during that 3 to 5 day window that they can actually go out and infect quite a few people. But for individuals that have some of the chronic conditions we talked about before, like diabetes and high blood pressure, it's during that time period that now the virus has been beginning to replicate at a very high rate and turn on the inflammatory proteins. And you may not have an opportunity to build up a big enough or robust enough antibody response because of the fact that it's taking a long time for the body to recognize and then build up the antibodies. So, apologies. So here, we're showing there were multiple studies going on all around the world. As a matter of fact, there were over 200 entities, whether it be universities or companies all around the world, that were actually trying to come together and develop vaccines. Of that, I chose about 5 or 6 here that were here in the United States, and the ones in green are the ones that are actually being approved, and with Moderna now being approved just earlier today at about 4 o'clock. And they work by a technology called messenger RNA. So we're going to talk more about that in just a moment. Now, it's also very important for all of us to really understand. It really does feel like it was rushed. And I'm going to show you exactly how unrushed it really was. But in record time, we were able to put over 200,000 people around the world into clinical trials. And there's a great possibility that if we include China and Russia, that number was about almost close to 1 million people that were in clinical trials for the development of various vaccines. And so here you see Moderna had about 30,000 people and Pfizer had about 45,000 people. So it's really important to understand that we've had one of the most robust clinical research programs for a vaccine ever in the history of vaccines. So I know it feels like it happened quickly, but it was not done haphazardly. Now here, I'm going to show a little bit of data just so that you all can get a sense of exactly who were in the clinical trials and actually how many of us in terms of African American or Latino descent, we actually played a big role in it. Here we find that it was about evenly split between men and women. There were more people that were 18 to 65, And also, but when you get down to the race, now obviously there's going to be far more white or Caucasian people that were in the trial, but in both trials, whether it be the Moderna or the Pfizer vaccine, both of them approached having about 10% of the people in the trial. And very often, as African Americans, we barely get to anywhere from 1 to 3% of any clinical trial. So we've had a threefold increase over what we could have normally expected in a clinical trial. So that's a very important thing for all of us to understand. And here also you find Asian and others. Also for our Latino counterparts, they played a very big role in both clinical trials. A big part of that happened because they were down in South America. Okay, so another question I've been getting a lot of, because people are concerned about, okay, you're going to inject it, but what is in the vaccine? The first thing I'm going to tell you about both of them here, the Pfizer vaccine and Moderna, they are preservative free. That's one reason that they have to be kept at such a cold temperature, okay? They have no preservatives in there. And without getting into every other component, here in the Pfizer vaccine, we find some very common things that we're all familiar with. Cholesterol. They come up with like a little fatty acid component that they put into the vial and then they freeze very quickly. Sodium chloride, which is common table salt, or sucrose, which is a sweetener. And so we find these different things, and we find it not only in the Pfizer vaccine, but also in the Moderna vaccine as well. Now, these vaccines, I'm going to show you exactly how they work, and I'm going to go through it very quickly because I really want to get to our Q&A. But what they did,
looking for some other kind of dress.
So what they did here, they took a little bit of the RNA and they coded it. Now they don't get it directly from the virus. They took the genetic code and they duplicated the genetic code from it. So they're not getting any part of any live virus. There is no live virus vaccine out there. And then once they did that, once they were able to get and kind of recode and duplicate that messenger RNA, they then put that into your body and they tell it, and it tells your body to actually manufacture those little red spike proteins. So it's almost like if you could imagine that, they're almost injecting little red glitter inside of your body. And it cannot make you sick. It will not make you ill. You cannot become infected. You cannot get the virus. None of that can occur. But what's really important is that your body now builds the antibodies to the red spike protein, the way it would have done if you became infected naturally. And so once they actually got that accomplished, now they actually have the ability to go out and form these antibodies and have an army of antibodies in your body ready to defend you in case you actually come into contact with the real virus through natural means. And so we have to really begin to understand the vaccine. I've seen and I've heard a lot of things on social media. It's not what we think it is. It's nothing. We're not injecting people with anything dangerous. There's no preservatives in these two current vaccines. And more importantly, we're not injecting people with any radio frequency devices. I've heard all kinds of things. No, that is not true. And I'm going to show you exactly how we know that with oversight from African American physicians and researchers all across the country. So I know it feels like it came along very quickly, but I want to let you all know that we actually have been planning and working for the next pandemic starting a number of years ago. We knew there was going to be another pandemic. And we knew at that time that we could not wait a 2-year period in the way that we normally probably would have needed to do to build a vaccine. So they went and they relied upon brand new technology to come about and be ready for the next pandemic whenever that did occur. Now, it's really important to understand, and what I'm showing you here, this is from an article in 2013. Way back in 2013, the company began working on the platform and the technology for this messenger RNA. and they were waiting, and they needed to be able to do it and respond to it very quickly. So no, we didn't wake up in April of this year and say, hey, let's try this brand new messenger RNA technology. We have actually been working on it for now a 7-year period. Now, this is from an article that was published a little bit earlier this year in August. And the one thing I want to let all of you know is that the individual that actually advanced the technology, that put support behind building the messenger RNA for the first 2 vaccines, at least, that have been approved, was actually President Barack Obama. And it says here, and this is a quote, President Obama's decision to invest in mRNA vaccine research, which is one platform being used to develop potential vaccines in record time. And this individual went on to actually talk about the fact that, that he invested $150 million back in 2014 and 2015 because he knew that one day we were going to need that vaccine. And so I took it one step further, and I went and actually found a speech that Barack Obama gave back in December of 2014. And again, I'm not going to read the entire thing, but I've highlighted here in yellow, and I'll read a portion of it. Barack Obama said, so that if and when a new strain of flu, like the Spanish flu, crops up 5 years from now, or a decade from now, we've made the investment and we're further along to be able to catch it. It is a smart investment for us to make. And so again, he began talking about the fact that yes, indeed, we were going to have a new pandemic. And we have to remember, he had to deal with 2 pandemics in his time. First, Ebola, H1N1 flu when he first came into office, and then Ebola after that. Now, fortunately, we didn't have widespread Ebola here in our country. And Ebola is a very hard virus to spread. Coronavirus is a very easy virus to spread. But either way, he knew that we needed to have the technology. And so here at the very bottom, based upon that technology, the same company has actually built and developed a Zika vaccine. But the point is, Zika was from like 3 or 4 years ago, but we've been able to do it very quickly. And so I know it feels like everything happened very quickly. We understand it feels like it happened very quickly, but in reality, what is happening now, we planned for 7 years ago. We knew another pandemic was going to come, and we knew that we were going to have to respond much quicker than we were ever capable of ever doing before. So I do want to give Donald Trump and Operation Warp Speed a lot of credit for taking that off of the shelf and saying we have a tool that we can turn around and make vaccines very quickly, and they invested in that, so I'm very happy about that. Now, it's also very important to understand that we had African-American physicians all across the country that were very invested in making sure that everything was very safe. And the National Medical Association, which is actually the Black Doctors Association, they were very key and instrumental in providing oversight and interacting with that COVID task force that we've been hearing so much about. And they were interacting with the labs, and they were interacting with Dr. Fauci. They've been watching and interacting with everybody. And so I had the opportunity to talk to the president and get to know fairly well the president of the National Medical Association. And we talked about what they were doing in response. And so we had a whole number of people all across the country because we understood that the Tuskegee experiment did occur. And we understood that many people in our African-American communities had a very valid reason why they may not trust a vaccine, and especially one that was going to come about so rapidly. So rather than stand back, we engaged in the process. You got people immediately engaged in the process, and we've been a partner along with them to make sure, number one, that they were going to do everything fairly, that it was going to be done the right way, but more importantly, that there was going to be equity and equality and distribution of the vaccine when it came out. I'm going to skip past that just for time's sake, but here I'm just kind of showing that along the way there were problems with a couple of the clinical trials, but you know what? When we halt a clinical trial, that means that the process worked, and we had safety built in for everything that we did. Now, very quickly, people are trying to figure out, some people, and I know many of you out there may be feeling like, I'm still not going to get that vaccine, but many of you may be changing your mind, or maybe some of you looked up and said, hey, when can I get it? Well, outside of the federal government, a group came together and they built a 4-phase approach to try and determine who would be the most appropriate people to get a vaccine when it became available. Number one, and we've already heard this in the news, if you happen to be a healthcare provider and you work in hospitals and you're coming into contact potentially with people who are COVID positive, they were going to be the first ones to get vaccinated. And they have been, we've been vaccinating people for about a week now. After that, people, the elderly, if you live in a congregate living area like a nursing home or an assisted living facility. Shortly after that, we have essential workers, and they're very important, and we put teachers in that category. And we're also trying to make sure that we include other essential workers, because you know what? They have been on the front line as well. And many of our African American and Latino and other people of color actually fall into the essential worker category. We want to make sure that from a point of equity that we get them earlier in the process, not towards the end of phase 3 or 4, but at least in phase 1C or phase 2, to make sure, you know, we're talking about people who are bus drivers, okay? People who are EMTs, people that do medical transport. So we want to make sure. So I'm going to bring this to a close here, but I wanted to also kind of remind our audience this evening. And once again, I just want to thank Alan Temple, AME. You all have been a pillar in this community for such a long time. And so I'm really happy to be here with you all this evening. But for all of our African American communities and all across the country, way back in the early part of April, I began to notice that, you know what, it seemed like African Americans were being more affected, and I began doing some research. And you can see here that now I put this graph together. I got this graph back in October, and we were dying at a rate of 2.3 times that of our Caucasian or white counterparts. And then earlier this month, I went back in that number. It kind of sort of seemed like it dropped down to 2, but I want you to pay attention here at the very bottom. Here we lost 41,000 people, 41,500 African American lives that have been lost to coronavirus. Now, at that time, that was 20% of all the people who had died from coronavirus, even though we only make up 13% of the population nationally. Earlier this month, in October, that 2.3 dropped down to 2. So now we were only dying at 2 times the rate, or twice the rate of our white counterparts. And then tonight I went back and I checked again, and that number has dropped down to 1.8. So now blacks are dying at 1.8 times that of our white counterparts. If you are Hispanic or Latino, you're dying at 1.5 times the rate, and the same thing with our American or Native Indian brethren. Now, it's really important to understand that even though that number is dropping, we're still basically dying at 2 times the rate of our white counterparts. The only reason the number is coming down is because now the coronavirus has hit the Midwest, where the majority of states out there have white or Caucasian populations that exceed 85% or more. So, and we don't want anyone to die. Okay, so it's not a question we don't want anyone to die. I'll just put it that way. And so here, I wanted to go back and again show you back in April, my fears have been confirmed that in every state across the entire country, that African Americans were being affected disproportionately when it came to COVID-19. Now, it's really important to understand, you take a look at a state like Louisiana, we make up 32% of the population in Louisiana, but we were 52% of the cases of COVID-19. So that red bar is exceeding the amount of people that are present in that particular state. And so we understood very early on that if you had high blood pressure, if you had diabetes or any other cardiovascular complication, that was exactly why we saw the early hotspots and why people were dying at such a high rate early on. Even though I'm showing you rates of 2 times the death rate, early on in the very beginning of it, the death rate was 4 times that of our white counterparts. And it's not because there's anything unique about us as African Americans. It happened to be more so because we as African Americans have dealt with decades and even centuries of health inequity. And we have much higher prevalence of diabetes, a much higher prevalence of high blood pressure, and a much higher prevalence of overall cardiovascular unfitness. And again, I showed you earlier that when you put that together in combination with that coronavirus, that you're in a very dangerous state at that point. And early on, we didn't have any therapeutics whatsoever. So even if you went to the hospital, once an African American went to the hospital, we were 4.7 times more likely to die in the hospital than our white counterparts. And a majority of it was not because we're Black, and it's not that the coronavirus is affecting us because we have melanin in our skin. It was affecting us because we have a much more poor healthcare status overall. And now we're finding that kind of shakeout among all races across the entire country. And so to kind of bring everything to a close, and here I'm gonna invite Dr. Hill to come back and share a little bit more about Reach Up here in a moment. But I bring you back to this slide here. And now we can actually begin to understand that we're not dealing with the flu. It's not just the flu. It's not a hoax, okay? It's not just a respiratory infection. We're talking about a virus that can affect so many different organ systems in your body. And so we have to do everything we can, in my estimation, to try and protect ourselves, to not let it affect us so negatively. And so, Dr. Hill, I'm going to pause here and just let you share a little bit of information about We Care and some of the work that we've really been doing. And one more time, right before she starts, I have to one more time talk about Reach Up, because now we have done greater than 25 of these sessions out here in the community. And we've done it for every segment that we can get our hands on, and we will continue to do it because it is so important that we fight to live. We have the right and the opportunity to live a good life. And so, Dr. Hill, can you share what We Care is and what we're trying to accomplish?
So first of all, let me just thank you, Dr. Sneed, for providing that insight on the COVID vaccine. And I do hope that our listeners gained a lot of information because it is so important that we all understand that this is real and that the decision to have the vaccine, as I said earlier, really should be hinging upon information like what Dr. Sneed shared tonight. One of the opportunities that we've had with our We Care work is to certainly touch communities of the African American community, but we've also bridged relationships or strengthened relationships with the Hispanic and Eastern Indian population and others. And we're even talking to Nigerians and our other Afro-Caribbean brothers and sisters, again, trying to share the message about the importance of research participation. And as Dr. Sneed talked about, the numbers are never where they need to be. So we are open to collaborating with others that share an interest in making sure that we know and understand the importance of medications and how they would work in individuals that may be Black or brown. And so not only are we talking about COVID, but we're looking at other health disorders, particularly those that affect the underserved and underrepresented. But just like Dr. Sneed showed the slide where we're contracting COVID more, and it's because we're more at risk for a lot of the comorbidities like hypertension and diabetes that unfortunately are also plaguing our communities. And so we have been partnering with Moffitt, doing workshops related to all kinds of cancers. Our national partner, 50 Hoops, also has allowed us to certainly communicate with the MD Andersons and the Duke universities and other big research institutions to share our story regarding our passion for trying to make sure that people understand that there are opportunities to really help us in terms of recruiting and retaining individuals in research. So when we look at We Care, one of the things we really pride ourselves on is trying to bridge the academic community with the core community by expanding knowledge like we did tonight, and certainly engaging with you, not just for these kind of workshops, but certainly for future things, so that we can be a resource to you and help walk you through it. And then in turn, we hope that we empower you, both arming you with information and an understanding of the benefits of research participation, as well as the outcomes that can come from it. One of the other things that we've done is work also with researchers to make sure that they understand that there's a necessary effort to maybe culturally tailor approaches for trying to recruit and retain participants that do come to their trials, because we do understand, as Dr. Sneed said, when Moderna got started, they went to Miami, but didn't really have a plan on how they were going to approach the Hispanics and other minorities in the area. And unfortunately, they didn't get the enrollment numbers that they were anticipating. And so we're hoping that with our efforts to educate first, we can empower people, and then you can make an intelligent decision about whether or not you want to participate. I think in our next slide, Dr. Sneed, if you would advance it, I just wanted to kind of show you this guy here. You might notice him, and he didn't go have a flu shot, but Dr. Sneed actually went and had his COVID vaccination. And so he's showing in the picture here where he got it, and I'll let him talk a little bit more about what that experience was actually like.
Yeah, well, to be honest, there's not really a whole lot to share. But, first of all, Dr. Hill, I called. My mother told me to give her a call before I went, and she immediately broke out into prayer. Okay, she said she just broke out into prayer for me. But to be perfectly honest, and I do apologize because my slides got a little bit out of order. I was going to go through and talk about some of the adverse effects that can be anticipated. But to be perfectly honest, I want to share with all of you, many people are worried about that, but I'm not worried about it at all. And to be perfectly honest, I didn't have any really of the bad side effects. And to go one step further, I took some Tylenol just to make sure. And so the most prevalent side effects that are really occurring for many people have been really the most prevalent side effect for both vaccines right now with both companies has been fatigue. Okay, and so when you feel that fatigue, after that, some people have had headaches. A smaller number of people had chills. All of that occurred for only about a 24-hour period. Okay, it occurred for about 24 hours, and for individuals that had that, even during the clinical trial, if they took simple Tylenol, that tended to resolve many of the overall symptoms. Now, each one of the vaccines has to be given twice. You're going to have to go and get an initial shot. And then if you got the Pfizer product, you have to come back in about a 21-day period. If you get the Moderna product, you'll come back in a 28-day period. Now, in all of the clinical trials, and I've read all 53 pages of both reports, and I've got it right here. And I took a look. I do have to let you know that most people had the majority of the side effects after the second shot, not during the first shot. But even when they had that, the overwhelming majority of people actually took Tylenol and did not have a problem. And so I'm going to stop sharing right there. And if we still have my good friend Brianna Robinson, and I want to thank Brianna really for being the catalyst for setting up this evening. Immediately she jumped on board and said, hey, I want to bring this to my church. And I said, let's talk to Reach Up and get it all scheduled. And here we are. But I felt it was very important that I can't come out to the community and tell you to do something if I'm not willing to do it myself. And so I have done it. And to be perfectly honest, I did it yesterday. That was a picture taken yesterday afternoon. And I'm here hanging out with you all tonight. And I had a full day. I woke up this morning and everything, but I feel much better. I feel much better about my possibility for protection. I feel better about the possibility of not bringing it home to my wife and my children. I feel much better about the potential to actually encourage other people to want to do the same thing and overcome the fear. And I understand the fear. I really do. I get it. But death from coronavirus has hit our community right here. Many of us know someone who has been affected. Many of us know someone that may have died. One of our really important clergy right here in this Tampa Bay area succumbed here recently. And so I just want to be available tonight to answer any questions that you all may have, or even take any comments. I want to hear all of it, the good and the bad, because it's really important, and we need to have that conversation. So I'm gonna engage Brianna and Dr. Hill and Dr. Austin here to help me navigate through any questions you all may have. But please take advantage and take a moment. If you have a question, we want to try and get it answered tonight. But thank you so much for the time. I want to thank Dr. Hill and Dr. Austin one more time. My good friend Hiram Green, who's always there in the background. I can't wait to, Doctor, you know what, Dr. Hill?
Mm-hmm.
It hurts my neck more to look up at 6'7" Hiram Green than it did to get that shot in my left arm. Okay. Hiram Green, he is a man born of angels, and so we're just very fortunate to have him. But are there any questions at all from anybody out there?
And I would encourage, for those of you that are on Zoom, you can put your questions in the chat. And then we'd like to ask Ms. Robinson if you would share with us any questions that may be coming through via Facebook Live. Well, while they're getting ready, Dr. Sneed, I'd like for you to explain to everyone kind of why they have to have 2 shots and why couldn't just 1 shot do?
Okay, yeah, that's a very good question, Dr. Hill. Yeah, so the way the initial shots work, when they begin to turn on your immune system early on, we don't want to turn it all on at one time. Okay, and it's not even safe to turn it all on at one time. So we give you an initial shot, and your body has an opportunity to peak at those little red spike proteins I talked about. And then when you come back, we give it a booster, and we tell the body, okay, you've made a few antibodies. Now we want you to make a lot more. And it's when you get the second shot that you get the full protection. I did not have time to add it in, and I wanted to, but right now, after you get the first shot, you only get about 50% of the protection that you should get overall. But then after you get the second shot, that effectiveness rate goes up to about 95%. Mm-hmm. And so we want to be sure that if you get the first shot, you must go back for the second shot. You are not conferred full protection if you don't get both shots. So it's very important for that to occur. So thank you very much, Dr. Hill, for asking me, for reminding me to share that information with our people this evening.
Okay. Well, we haven't gotten any questions. Go ahead, Dr. Green.
Yes, thank you so much. I just want to say, because I'm the only person on this group who's not a doctor, even though they call me doctors. And I just, but I want to say this, because I said that because of this. I had an opportunity to serve on what we call the Institutional Review Board for about 15 years at the university. And one of the things that board does is we monitor the very things that we're dealing with now. Why I'm so excited, particularly as an African American, about what's happening is because I used to go and ask the question all the time to the docs on that committee, are we going out to the African American community to talk about this research? And they would say, we're trying, because there are a lot of protocols that exist there. But now with Dr. Sneed, Dr. Austin, Dr. Hill, we've taken another step. They are now out there for our community to be able to ask the questions, to determine what's really happening. And we didn't have that before. This, now we have it, and I'm excited about it, because being a layperson means I'm being a person who doesn't have a doctorate degree and I'm not a doctor. I'm excited about what We Care and this group is doing for our community, because we've never had it before. And I think that is a great opportunity for the community to really draw from these doctors. And so I would ask you to please take advantage of it, because this is something we've never had before. So I just wanted to share that with you.
We have a question here from Miss Mobley. Miss Mobley, this is a very important question, and I want to just share this with you. And it's reminding me to share another important message. She says, I'm a school nurse and I practiced social distancing. However, she did test positive. One of the really key things that we learned early on was the fact that the coronavirus can actually aerosolize and get in the air. Now, it's not what we call airborne. Airborne would be almost like pollen. It's something that it would be able to blow and be sustained for many miles in a long period of time. But if indeed an individual coughed, or we're talking loudly, or if we happen to be like in a church setting and we have the choir and people are singing loudly, that actual virus can actually escape from the nose and the mouth and get into the air. Another thing that we found out early on is the fact that you can become infected through the eyes. And so because of that, one of our researchers here, we actually have him trying to develop an eye drop that, number one, we think can be a treatment, but we're actually looking at it potentially being protective for the eye. But also, it's important to understand that even when you do everything correct and everything properly, this particular virus is waiting and is looking for an opening. And so even sometimes if you wear a mask, if we don't have the mask on properly, or if we happen to have it down and we're not covering the nose and the mouth, we can not only can we give it to people, we can inhale it. Again, I talked about the eyes. So when I go in clinic, and I'll show you, I made sure I brought it back this evening. When I go see my patients in our clinic, I actually wear these goggles, okay, to protect my eyes just in case. We have everybody. That's why you see everybody wearing those face shields. Although I don't think the face shields are going to be as effective as a goggle. That's why I wear the goggles. Mm-hmm. So, Ms. Mobley, I think you know I think you're the perfect example of people that actually try to do everything correctly. There's also a sense sometimes that you can have such a high viral load, what we call it. There's such a high content, a high amount of the virus hanging around that it actually can, in some cases, begin to penetrate the size or the mask overall. And we have found a small number of people in healthcare settings, in emergency rooms and other hospitals around the country that became infected. And that's why we're trying to protect our healthcare providers up front. And they saw so many people and there was so much virus around that they actually became infected themselves. And so we need to do everything we can to protect it, but it's not 100%. We have not found 100%. Even the vaccine is not 100%. It's close to it, but it's not 100%. And so I think it's very important. I think it was a very important question that you asked, and thank you very much for asking that. I hope I answered your question.
Mm-hmm. So, Dr. Sneed, we have, I guess they're taking Mr. Green's advice. We've got 3 questions that Ms. Robinson has put in the chat. The first one being, what are some possible future effects of the vaccine, like how they have commercials for past diseases getting compensation for medication? And then the second one is, if you have an autoimmune deficiency, will you be able to take the vaccination? And if not, will they come out with one? And then again, has there been any major side effects of the vaccine, which I think that you commented on in people in the front lines?
Yeah, so the very first one about future effects, and this is something I'm very passionate about overall. Thank you for that question that may have come in from Facebook Live. At this current moment, the virus has not even been around. It's only been around, if you think about it, now for about a 13-month period, maybe 14 months. So we haven't even had this particular virus around for a long period of time. And so clearly right now, we don't have any expectation or any insight into what the potential long-term effects may be. But the one thing I often tell people, and I know Dr. Austin has heard me say it so many times over this journey that we've been on together, is that we actually do know what this particular virus can do to you. And the thing that has scared me as a clinician, as a microbiologist, as someone that understands the biology of the virus, it scares me, is once you become infected, and I talk to you about all the various organ systems, we don't know how long those organ systems may be affected. I have a patient right now. Well, it's the spouse of one of my patients. She became infected back in April. She lost her smell. It is now December and she still does not have it back. She may never regain that smell. Now, I hope she does, and other people have recovered, and it's taken a little bit of time. We have people out there with what we call the brain fog. You know, I had another patient, he was a top performer in the company, and now he can barely think. He can't perform at the level he did before. I have another patient that was a nurse well, I won't even say where, but he's on disability now. He can't even get back to work. He's so negatively impacted. And so the actual virus getting infected from the natural virus is just a way right now that it says, you know, I don't want to take a chance on what the long-term effect of the virus may be. But that's another reason, and whoever asked the question, I'll get Brown, I'm going to give you credit for it for now. It's really important to understand that the current vaccines that have come out, they have no preservatives in them. They have things in them that we commonly consume every single day. Sucrose is a form of sugar. Sodium chloride is salt. Lipids is a form of cholesterol. And so they have, it's a fairly natural base that they've put it in. So we do not anticipate at this current time anything happening long-term. Many of the long-term things that we have heard about, or we think that many decades ago may have been associated with the vaccines, have been clearly removed from many of the vaccines being produced today. So I just wanted to share that. The autoimmune deficiency, we do not have enough clinical data right now to support yes or no whether or not we should or we should not. And that will be a conversation that you would have to have with your physician that's managing your condition. However, I will tell you that if we identify people, for example, like whoever is asking the question, and you say, you know what, I have an autoimmune disorder, and I'm even being treated with medication for that autoimmune disorder, but I still want to take a chance and get the vaccine. We can actually have your physician call the company up and say, hey, you know what? We have a candidate here that you may want to follow. Okay, you may want to follow the individual. And the most important thing that we would do with you is probably get an antibody level from you somewhere down the road at a 2-month period, a 6-month period, 1 year later. Everybody, by the way, that has been enrolled in the clinical trials, they enrolled in the clinical trial for a 2-year enrollment period, not for just the initial shot. So we're going to follow people for a 2-year period so that we can come back and ask that question. Now, in the Pfizer study, we did have people that were HIV positive in that study. We did not enroll them because they were HIV positive, but they did work their way into the study, and we found it to be effective even for the people that have HIV. So I think that's a very important question. And I've already talked about some of the other major side effects that you may want, you may expect to have. But again, in every clinical trial, and right now I'm living proof, everything only appears to last for about a 24-hour period. And so, if you get it on a Thursday, you might maybe take Friday off, and by Monday, you're going to be ready to go back to work.
So one additional question is regarding trials that have been performed in children.
Yeah, let me talk about this. It's something, again, and right before I answer this question, it's kind of almost in the self-marketing mode, but I want to share with you exactly how I'm able to kind of put this knowledge out there. And Dr. Hill has heard me say it so many times now. Beginning on March 3rd, I began reading and I became fascinated with this particular virus. And so I have literally read over 300 peer-reviewed articles about this coronavirus. And I mean everything from the cellular all the way to behavioral and health equity and health inequities. And so the question about children, one of the reasons right now that the Moderna product got approved today so quickly, and last week they had a lot of discussion about Pfizer last week, was the fact that in the Moderna trial, they only allowed people 18 and above to get in. And in the Pfizer trial, they actually allowed people as low as 16 to get in their trial. And so there was a lot of conversation with the FDA panel about the people that were less than 18. And what Pfizer and I believe Moderna is now doing right now, they're doing what we call a bridge study, where now they're going to go back in 3-year increments, okay? So they'll go back from 18, they're going to go down to 15, so 15, 16, and 17. And they're going to begin enrolling children in that age group into the trials. And then they'll go back from there when they get good safety data, and they'll go back to a 12-year-old and eventually 9-year-olds. And so now it's going to be very difficult when you get into people less than 10 years of age to put a child in a clinical trial, because, you know, we're very protective of our children. However, what we're trying to do now is gather all of the safety data to support whether or not children should be allowed to get the vaccine and what the proper dose would be. And they're doing those trials right now. And they do indicate that they believe that they will have enough data to potentially vaccinate children before the school year next year, beginning in August and September of 2021. And so those trials are happening right now.
Thank you, Dr. Sneed. So you commented on the concept of, or could you comment on the concept of herd immunity? And if enough, you know, are sufficiently vaccinated in this first period, will this assist in decreasing the number of cases amongst those that haven't been?
Absolutely, absolutely. Yeah, absolutely. That's a great question. Let's talk about herd immunity very quickly, because it's very controversial right now. And a report came out yesterday, and I have not had an opportunity to read the entire report, but I intend to read every word. The concept of herd immunity is that you get to a point where if you get enough people that have antibodies to any particular disease, or we'll say right now a virus, that eventually enough people in that population will actually have enough antibodies so that if they'll be protected and you won't be able to pass it from one individual to another. And we have an estimation right now in our country that we needed to get about 70% of the population with antibodies to the coronavirus to reach what we call herd immunity. And so now the other 30% that don't get a vaccine or were not infected, that don't have the antibody, they are still susceptible, but less likely to be able to spread it widely to a large number of people. And so thereby, if you reach herd immunity, by definition, you decrease the transmissibility and the opportunity for people to become infected when you basically cannot allow the virus to live and spread from one individual to another. Now, it's very important to understand the other component too, and this is why we are very high on the clinical trials and the vaccine. We have variable immune responses that have occurred in people all over the country. Some people had a very robust immune response and they developed a lot of antibodies. Some people had a very weak immune response and they didn't develop that many antibodies. And therefore, until we have what I'm going to call, and I don't know the number, but what I'm going to call a requisite amount of antibodies in your body, that does not mean you're protected. And so now we are now having multiple cases. I think there's about 30 documented. And when I say documented, I'm talking about where they took samples and they did the DNA, or I should say the RNA, not DNA, the RNA sequence of the virus. And they confirmed that an individual has been infected on multiple occasions with 2 different strains of the coronavirus. That, you know, we are concerned about that, and we are even concerned about the fact that if people did not have a very good immune response the first time because they just barely got enough of that virus in their nostril, well, then they may become infected again. Now, the other thing we're trying to study is another part of your immune system called a T-cell response. Some people have a very good T-cell response, and some people we are questioning if they do. now the next part of the vaccine study will be to see whether or not we can get the body to build up T cell immunity, so that if you come into contact, not only do you have antibodies later, I'm talking like months later, but if you have it, you actually have a part of your immune system that will come in and try and kill the virus very quickly. And so right now, we don't know how long the antibodies are truly going to last in your body. It could be a 6-month period. It could be a year. But right now, we're probably anticipating that we're probably going to turn the coronavirus vaccine into an annual event. So very good question. Very, very good question about herd immunity.
Well, Ms. Robinson, do you have any more questions on your end? Okay. I don't see any more, but we certainly encourage everyone to definitely make sure you capitalize on Dr. Sneed's availability to ask him any questions at this point.
And Dr. Hill, while we're waiting, there's another thing I want to, and I'm going to turn everybody into a schoolhouse scientist real quick because it's something that we've all done before. At one point in time, all of us have probably, when we were in school at a much younger age, let's say we had food coloring of, say, some blue water, and we had food coloring of some yellow water, and when we added them together, it turned green. Okay, and we've learned how to add food coloring and produce all these different colors. The reason I bring that up, if you become infected by the actual by the coronavirus in a natural and out in the natural environment, what it is doing is combining and taking part of your proteins, and it's combining the same way those two liquids did, and that's how it will wind up infecting you and potentially causing damage to your body. That's why we're trying to encourage people to build up the antibody in the same way you saw the video, so that if you come into contact with that coronavirus, that it will actually block the virus from being able to attach to any organ in your body. And you already have a built-up immunity against it. And that's kind of how it's going to work. We don't want that RNA from that virus to get in and mix with your body's RNA and take over and now produce more of itself. We don't want that to occur at all. And getting back to the herd immunity, if indeed, if anyone becomes infected, part of the reason that we were trying to shut everything down, we were hoping that enough people who were infected, we would allow the virus to die within that individual, and they would not be able to spread it anymore. Well, we just weren't able to accomplish that as a country. And so now, now we're watching record surges happening from Thanksgiving. And we're really worried about what could happen between Christmas Day and New Year's Day. And that may produce another surge after that. So again, we're going to encourage everyone. Hopefully I've changed a few hearts and minds, and you'll consider getting vaccinated. But until then, we need everybody to continue doing the things that Ms. Mobley talked about in her question. We still need you to wear a mask. We still need you to try the physical distance, and we still need people to try and wash their hands and not allow it to spread. We need that to continue to occur no matter what. Until we get enough people vaccinated, or you yourself choose to be vaccinated. And I anticipate right now that more of the vaccine will be available probably by the middle or end of January. And then from that point on, I think you'll be able to go to your local pharmacy and be able to get it after January, probably in February and March.
So Dr. Sneed, another question Mrs. Mobley asked is, would you recommend frequent testing for COVID until we get the vaccine?
I'm gonna say yes, within reason. Of course, if for anyone that may potentially be in environments where you're going to potentially come into contact with the virus, we want them to get tested more often. The earlier you find out you're potentially infected, the earlier you have a chance to get away from other people so you don't infect anyone else. And if we can, and if you do become infected, we can allow that virus to die within you, okay, to not be able to spread, and hopefully you'll be treated. And Dr. Hill, Ms. Mobley, we need to add Ms. Mobley onto the team. She's asking some great questions here, and she's a nurse. I want to share with all of you, and we don't have a lot of it out there, and I don't talk a lot because I really want to focus on vaccination. But for anyone that may become infected, if we catch you quickly enough, there is another, they're what we call monoclonal antibodies, where we take antibodies to the coronavirus, and we can just infuse it into your body. This is the very treatment that Donald Trump got when he became infected. And then most recently, we saw Rudy Giuliani get it. And so, but we don't have a lot of it. It's very difficult. At one point here in the Tampa Bay area, we only had 50 total doses to be able to give out. I don't know how many we have now. But if you do become infected, you should inquire about it. Because right now, at least, even though it costs, the general cost we expect it to be is about $100,000 per individual. If it's available and you fall into a qualified group, you can actually get that treatment for free. It has already been paid for by the federal government, but it's very hard to produce a lot of that monoclonal antibody, which is why it's not a good strategy to wait. But yeah, but if you're in a high risk environment, testing a lot. But if you're not in a high risk environment, if you're not around many people, if you're around the very same people and none of them have been affected, then frequent testing wouldn't be prudent at that point.
Thank you. So one of the things we'd like to ask all of our participants this evening is if they would look in the chat section. We have a survey that we just want to appreciate your position after hearing the information Dr. Sneed shared tonight in regards not only to the COVID vaccine, but just certainly overall your readiness to take the vaccine. And if there are other areas that you're interested in related to this or other health-related topics, please make sure that you reach out to us. I'm going to place my email in the chat, and I also will ask Dr. Austin if she didn't mind sharing her email for the purposes of you following up with us in the future in the event that you'd like to speak to us. Mrs. Robinson has placed it or sent it to Facebook for those of you all that are participating by that mechanism. We certainly want to thank all of you for your attention tonight, and we hope that this won't be the first time that you will participate in a program offered by We Care. We certainly are going to continue educating as many people as possible about this topic, but we also will have other topics coming up. So don't be surprised if you hear from us via email inviting you to future seminars. We have some programming that we're going to be collaborating with other civic and social groups, and we certainly want to include you all. I think you'll find it very valuable. But certainly think of We Care as a resource to clarify and to explain and to arm you with information so that you can be ambassadors on our behalf. And we ask that you go back and share this information with your families. And if any questions come up after tonight, feel free to reach out to Dr. Austin or myself, and we'll make sure that if either of us can't answer the question, we'll get it to Dr. Sneed. To make sure that you feel comfortable and know as much as you can about this and other issues. Time just doesn't allow us to cover every aspect related with this issue, but we do hope that tonight's information was helpful. And again, we do appreciate you and would just like to invite you to complete the survey. And Ms. Robinson, thank you so much for coordinating tonight's workshop. Ms. Mobley and others, thank you so much for asking questions. And we do wish all of you a safe and wonderful and enjoyable holiday, despite the fact that COVID is at the paramount of our mind. We have so much to be grateful for. So we do ask that you stay safe, follow the CDC guidelines, but just know that we truly care about you. It's not just a name. We really care about you. So thank you so much for participating tonight, and we hope to see you again in the future.
I really want to thank Allen Temple AME Church again, such a long-term pillar in the community. My church is not far from there, St. James House of Prayer. And so I'm really thankful for the leadership, for Dr. Dames and the whole leadership there to just be able to allow us to come and interact with you all this evening. Brianna, I want to thank you for your interaction as well. And we look forward to partnering even more with Allen Temple AME in the future. So thank you all very much for this evening.
Mhm.
Are we done?
Yes, ma'am.
Oh, okay.